Hey folks, today's episode was sponsored by Datadog. It's a cloud-scale monitoring and analytics platform. Datadog was built to bring clarity to complex dynamic applications in the cloud, on-premises, in containers, or wherever they run. With beautiful dashboards, distributed tracing, and seamless integrations with more than 200 technologies, including Azure and Docker and PagerDuty, Datadog provides deep end-to-end visibility into the health and performance of modern apps. Visualize key metrics, set alerts to identify anomalies, and collaborate with your team to troubleshoot and fix issues fast. I'd like you to try it yourself by starting a free 14-day trial today. Listeners of this podcast will also get a free Datadog t-shirt. Get started at bit.ly.com/DatadogShirt. That's bit.ly.com/DatadogShirt. Hi, this is Scott Hansel, and this is another episode of Hansel Minutes. Today I'm talking with Cecil Phillip. He is the host of the Away from the Keyboard podcast at awayfromthekeyboard.com, and he works on serverless at Microsoft. How are you, sir?
Doing pretty good, Scott. How you been?
I'm chilling. There's no more snow, so I'm feeling good about that. We had a lot of snow and we were stuck in the house for a week last week, but it is all good now. Well, actually not last week by the time this has aired, but last week by the time we recorded it.
So let me tell you a funny story to that. So all of my life, I'd never seen snow up until January of this year, January 2018.
You're lying.
No, so think about it. I grew up in an island, so it obviously doesn't snow there. And then I live in Florida. Doesn't snow here either, right? So the first time I saw snow again in January, me and my family went over to Denver, and I took my son. I have a 5-year-old. I took him skating. We went on the hills and we went sledding and all this types of stuff. And when we opened the car door, like he runs out the car and goes like face first into the snow. And he's like making snow angels and he's playing around. And then I'm kind of just like, I don't know about this snow stuff, man. But it was a lot of fun though.
What is that like? This is totally not the topic of this podcast, but you intellectualize snow. You've seen 1,000 movies. You've seen people stuck in the snow and they, everyone lands, there's a plane crash and they all are trapped in the snow and then somebody has to eat somebody else. Like you've seen all that. Yeah. But when you're in your 30s or whatever and you intellectualize, do you sit there and like pick the snow up and look at it and like look at it close and try to register? Or did you just like nonchalant, just jump out of the car? You're like, yeah, snow first time, but whatever.
When certain animals in the animal kingdom see something that's foreign to their environment and they kind of look at it from a distance and then they like slowly start to edge towards it to be like, okay, I think this is okay. I could play with it like that. It was very much a lot of that. So it's, it definitely wasn't as bad as I thought it was going to be. I thought I was going to be like frozen head to toe, but it wasn't bad. We did okay.
Interesting. Well, some cultures have multiple words for snow, and like snow in Portland is not snow in Canada, is not snow in Maine. So I don't know if you were in Denver on a mountain, maybe you got soft, powdery snow and not mean, angry ice ball snow.
Yeah, it definitely wasn't like 2-3 feet of snow or anything like that. It was, very small, fluffy, powdery type snow.
That's awesome. My 10-year-old, I just literally yesterday, opened up the freezer to get some ice cream, and there was a snowball that my 10-year-old apparently was saving, sitting in our freezer. So then he pulls it out and he throws it at his brother. But you're probably familiar with how these laws of thermodynamics and things go. Sure. It turned into an ice ball. You know what I mean? And then, frankly, I'm lucky he didn't put it right through the TV set. So that was bad.
Oh my gosh, that's crazy.
Yeah, not cool. Okay, enough of this. We're wasting people's times. I wanted to talk to you about serverless, and everyone is using it as the buzzword. First it was microservices, then it was containers, now it's serverless. And I've been reading articles about it, and a bunch of these articles are saying serverless / FaaS. And I know what IaaS is, infrastructure as a service. I'm pretty sure I know what platform as a service is, but now I feel like people are taking serverless functions as a service, implying that they're the same thing. Then there's backend as a service. I'm very confused, so I called you. Sure.
So when most people talk about serverless, kind of like what you said, they assume that we're talking about functions as a service, which pretty much just means that, hey, I'm going to write some code, I'm going to give it to somebody, they're going to run it for me, and I don't have to think about anything else that's happening in the background. right? And from a high perspective, that's really what serverless does for you, right? Like it allows you to build these applications without having to worry about servers, without having to worry about, machine updates or anything of that nature. Now, when we talk about FaaS or, FaaS, what we're talking about is, serverless compute, right? So again, I'm going to run my Python script. I'm going to run my, Java, whatever type of app that I'm building. I'm going to send it over to AWS. I'm going to send it to Google Cloud, whoever's actually running that code for me, and they're just going to run it. Now, some of the other things that we get inside of serverless is we also have serverless databases, for instance. So like say you're talking about something like Cosmos DB or even DynamoDB. Because at the end of the day, like whenever I provision this database, right, the only thing that I'm going to say is, hey, just create this thing for me. I don't care where it lives very much. I don't care how big it is, the scale will just kind of expand for me as I need it to be. But I just want you to create something that I'll just use. And that's pretty much just how it goes.
It seems like there's a major shift in the industry right now where we are simultaneously excited about serverless and backend as a service.
Yeah.
But then with the rise of Kubernetes, you see Kubernetes people and smart people online talking about internals of processes and how they fork in Linux. And so it's like, while we are in the growing pains of serverless, we're all running HTOP, which seems ironic.
Right. So when we talk about Kubernetes is a little bit different, right? Because so Kubernetes itself is what we call an orchestrator, right? And in the world of Docker containers, so Kubernetes will take your Docker container or your Docker image, and it'll orchestrate it in a way that you say, hey, I want to have like 5 of these things, or I want to have 4 of these things, right? And it'll just kind of make sure that environment is in the desired state, right? That's kind of what we call these things, like desired state configuration. It's in the desired state that you need it to be in. Now, this is a little bit different from the serverless pieces, right? Because again, with serverless, I don't think about anything other than writing code and sending it off, somewhere for it to be run, right? I don't really care too much about the region. I don't care very much about like how it's being run. But I do care that someone is managing like that infrastructure for me. When we talk about Kubernetes now, like even though it's kind of doing some of that orchestration for our containers for us, we still have to manage that, right? Like we still have to provision servers. We still have to provision memory and RAM, like the right amount of resources that's going to be able to run that for us. So even though it does make things a little bit easier from a orchestration perspective, and again, managing multiples of these container images, like we still have to think about it. And again, depending on what you're doing and depending on the type of app that you're building, that might be something that you might want to have. Like that might be like your right level of abstraction. For serverless people, it's more, hey, I got a really cool idea, but I don't want to spend like, I don't know, an hour or 2 hours setting up machines and picking SKUs or anything like that. Like I just want to let me just write this code really quickly and then just put it out there. Right. And so what you get with serverless again is this faster time to market way of kind of just saying, hey, here's some code, just run it for me. Now on top of that, we do get some additional features from serverless, right? So we also get like the per second billing, which is, a big thing for a lot of folks. Mm-hmm. So when we talk about, again, like running VMs or platform as a service offerings in the cloud, like regardless of whether you're using these things or not, like you still have to pay for them. So again, I go up and I spit up like something on Heroku or on, Elastic Beanstalk and AWS. Regardless of whether I publish the app or not, regardless of whether somebody's actually using it or not, I'm going to get continuously charged whatever it is that my fee is per month. With serverless now, we only get billed per usage, whether that's per minute or per second based on, whoever your host happens to be. But now I only have to worry about compute or these resources like as a utility. So let's say, imagine it's like your electric bill, right? Like if you don't use so much electricity, then you're only going to be billed so much, right? So it's a very dynamic way of kind of managing those resources.
It seems like a lot of people though are doing things like running serverless things on Kubernetes. So they want to simultaneously think about things at the low level, but also provide a service to their customers, where their customers might be other people in the same company. You know what I mean? So it's like they use Kubernetes for its orchestration and for its management and for its auto scale, and then they'll run a serverless runtime on top of it. So they kind of get the best of both worlds. They effectively use their infrastructure better. They have full and complete control down to the smallest text file. But then their customer, like if I was your customer and we work at the same company, doesn't have to think about it.
And that's a use case or a usage scenario that we see a lot of folks doing. So again, I, as a developer, like I just want to be able to publish code really quickly and try it out, like in an environment where I don't have to think too much about, I'm setting up Apache or I'm setting up Nginx or IaaS just to kind of run these things. Particularly when you're in the early stages and you're doing like POCs, when you're doing like, you just want to, prototype really quick ideas. I just want to write this code, push it out, and let me see what's actually happening. And so from a developer perspective, from a productivity perspective, like your productivity goes up so much higher because you're not worried about some of these additional concerns. Obviously, if it's inside of your company, like your DevOps folks or your infrastructure folks are going to have to be managing that for you. But even from that perspective now, again, your productivity is so much higher as a developer because that development model just allows you to iterate that much faster.
Right. I mean, the whole point is to put the person's business, get the person's business problem solved, so that random line developer isn't FTPing stuff or thinking about production and thinking about DevOps. Right. The goal is check code in, have code run in scale, right, without having to think about anything. Like basically freeing my mental cycles.
Exactly. And, I actually remember when I first heard about this quote unquote cloud thing, right? And when that first came out, this is exactly what I thought it was going to be. I thought it was going to be, hey, I'm just going to have some application and I'm going to send it somewhere. It's going to run and I'm going to get a bill at the end of the month. It's going to be like, oh, okay, you use this much disk space and you use this much bandwidth. Like again, your software being built as a utility versus like some static resource, like a virtual machine or something of that nature. And so it's kind of good to see that we have this stuff now. And, I think going forward, we're going to see that just kind of continue to improve with more and more features.
Mm-hmm. The functions as a service, being able to take like a do it written in any language and then scale it is interesting. But then I also see backend as a service, PaaS, where it's like, like I know that, Azure had one of those and, Firebase is one of those, right? Where it's like more than serverless. It's really like almost software as a service, but it's like, I want a REST API to handles everything for my mobile app.
Yeah, we definitely see a lot of that inside of the mobile space, right? So again, you talk about Firebase, for instance. So Firebase today, I believe you can actually execute serverless functions. Again, so you could write some code and you could send it to Firebase and they'll run it. But again, on top of that, you get the authentication, you get the ties into Google Cloud Drive, you get, again, mobile notifications, you get tons of, and obviously you get the database storage too, their real-time database. So you almost get like, it's like this package deal. It's like, hey, give me some of the basic things that I need for an application, regardless of whether it's desktop, mobile, or whatever the case is. Here's some basic things that I need. Let's package it up and kind of give it to you as, as a service. And again, you get billed for it every month. You get billed for usage or how much ever bandwidth you use. But now your developers, your company, you don't need to worry about, how do I set up this Facebook app and, set up these auth keys or, how do I authenticate with Slack to, send it, to send it messages. All you have to do is just say, okay, hey, give me this thing, right? And I'm going to call your APIs. And then, depending on how much ever work that I do or how many ever requests that I send every month, that's what you're going to build me for. But now me as let's say I'm a health company or I'm working on insurance or marketing or whatever the case is, I could focus on just doing whatever it is that my business is good at. And I don't have to worry about I don't have to worry as much about security or disk space or any of these types of things, right? I could just go and get to work.
Which I think, I know I brought up Kubernetes and you set me straight about like what that does versus what like traditional serverless means. But when you look at a system, a large system that used a lot of different services as a serverless architecture, you got your browser, but it's going to end up calling an authentication service and some API gateway and then N number of functions. The functions are at one functions as a service place. The authentication service might be Azure or Amazon or Auth0. The database might be Cosmos or Mongo in the cloud. Another database might be somewhere else. Suddenly, I've outsourced my things either to one vendor or a dozen, any one of which could potentially go down, which then gets me thinking back to orchestrators like Service Fabric and Kubernetes, where I could still do that exact same architecture. I could still pretend that there are no computers, but ultimately, if I needed to, I could get to them by, I could get into the dashboard if I needed to.
Yeah, exactly. And essentially what we're talking about now is, again, I have these different slots of functionality that are kind of spread around the place. And how do I compose them together to create whatever my solution is? And that's kind of when we start talking about like microservices and things of that nature, right? And again, microservices from a very high level definition, just being very specific units of functionality that have been separated, but now I could kind of bring them together to make, I don't know, whatever my solution happens to be at this particular point in time.
Yeah.
And so what you see is it's very easy for us to kind of bring all of these concepts together, right? So I could create a serverless application and then kind of create it in a very microservice type manner, right? Because I might have different functions that have different concerns. I might have one that's concerned for logging. I might have one that's concerned for sending email or sending text messages via some third-party service. And now what I could do in the front end of that, in front of my functions as a service, I can have something like an API gateway or API proxy or something of that nature, so that it kind of groups together that functionality a little bit. So like I don't have to worry about kicking off to so many different endpoints. I could kind of look at one URL or one location, and then in the background, I could kind of fork off to, I need to go to this service over here or this service over here or that service over there. Right. But from my application's perspective, I'm just going to one place.
Yeah. In like traditionally, if you had like a shopping cart service and you add something to the shopping cart, the UI calls the business logic, calls the service, et cetera, et cetera. But with these more distributed applications, it's like you almost have DNS and load balancing at every possible level. So every single caller is sitting in front of a load balancer, and every single thing that can get called can potentially scale independently.
No, exactly. And again, that's another good thing about building in a serverless model, right? Is that I don't have to worry about the load balancing of some of these types of things, because the platform should be able to scale for me dynamically, right? Because again, I'm not managing the server, right? Like my hoster, my provider, whoever they happen to be, they're managing that for me. So whenever my load goes up, like they should be able to detect that increase in traffic and say, oh, okay, well, Cecil needs like 5 more machines or 2 more machines. Or, I could say, hey, this is after Christmas, the big shopping season is done. We provisioned these servers for him before. We could kind of take them down because he's not really using this much compute power anymore. Which is really interesting. So to give a little historical context to something that I experienced, I used to work at a company called 800.com. This is back when you could actually buy a 3-letter domain, and it eventually got bought by Best Buy, and this is pre-Amazon, right? Right.
And 800.com did this crazy thing. You can actually go and search for it. It was 3 DVDs for $1. This is right when DVDs were coming out, and DVDs were expensive, and we wanted to surprise everyone as what was going to become Black Friday started. So we said 3 DVDs for $1, and it completely changed the way our site scaled, because we went from everyone basically browsing and running around our read-only part of our site to everyone's trying to put stuff in their shopping cart, which is the right part of our site. And we ended up basically making subdomains for images.800.com and shoppingcart.800.com. And we didn't know we were doing it at the time, but it's this kind of classic problem where we solved it with commodity load balancing. It's just that the load balancing was seen by the user because they saw, shoppingcart.whatever.com. And then we had a shopping cart farm that was independent, from the images farm and the product catalog farm. but we did it all manually. So we did exactly what you just described, but we still ended up doing it kind of on our own.
When you really think about the time, the effort, the research, the trial and errors that you had to go through to do that, all of that can kind of be almost lessened or even completely go away if you're just like, okay, here's my code, just run this for me. Let me know when it's done and I could get my response back. Right.
It's almost like the best practices of, our grandmothers and fathers is now a checkbox, right? We've abstracted away all of the best practices. I like to joke that like the second page of my resume is now completely just a checkbox in a cloud somewhere.
Yeah, a lot of that operational type work has really just been automated based on some of the things that we're doing today inside of the cloud.
Mm-hmm. I also hear serverless and functions being compared to what are called 12-factor applications. And I'll put a link to the concept of 12-factor applications. But these are basically, all of the best practices. It's 12 factors that describe best practices like, one code base and lots of deploys and your dependencies are isolated, etc. But Adrian Cockcroft, who is used to be the one of the chief architects at Netflix, talks about how quickly you can bring up your app. Like if you can bring it up in milliseconds, the entire application, and then throw it away, then he says you can call it serverless, which I thought was a very bold statement. And I'm not sure I necessarily agree with that.
So when we talk about, again, like just being able to push your code and let's say you want to prototype an idea, like you want to do that really quickly, right?
Right.
So again, think about what it used to take when, you're working at your first job or, one of your first companies. Mm-hmm. And you're like, hey, I need a server to go run this code. I remember for me, that used to take me like 2 weeks.
Yeah, you buy it, right? You physically buy it.
Yeah, to physically buy it, or, I had to wait for an admin to provision like a virtual machine or something of that nature, right? Yep. And there's a lot of time that has to go by, right? Because again, you're controlling this infrastructure, right? So you have to create it, provision it, plug it in, install whatever updates, plug it into the network. And so all this time is kind of just going on and kind of moving forward for you. Mm-hmm. When we talk about doing that stuff in the cloud, right? Like the automation is there and it's a lot faster. But again, like anytime that you're doing something like PaaS, for instance, when your load goes up, like you still have to provision another VM, right? Mm-hmm. You're not doing it, but like the framework is still doing it for you. And so obviously with that, like there's a time to, for that provision to be complete. You know what I mean? And so within that time, you're still getting load. You're still getting requests coming in. People are still visiting your application, until, okay, this server's on and it's hot. Now it's like, okay, I could, fork off some of my requests and, they'll go over to that machine. And so what you'll see with the serverless environment, one of the ways that we kind of, and we as in like the industry kind of resolve this is kind of just having like a pool of servers that are already available for you. So when you send your requests over and you need to quickly, hey, I need to give Scott like 5 more machines. Mm-hmm. Typically, like there's a pool that I could just reach into that pool and grab out, 2, 3 machines, 5 machines, whatever the case is. And so now you don't have to wait as long for that to happen. Mm-hmm. Right. And so that's kind of how you get that dynamic scale a little bit, right? Like there's these pre-provisioned environments and, they might have, whatever they need to have installed in them. All that needs to happen now is that your application just gets copied over there, installed on the runtime. And now, these requests could start, forking off to these different places. Right. And so that's the way that, the latency or the time to scale kind of helps get reduced a little bit when we're talking about like building in the serverless environment.
One interesting point that was also made was if you are providing this as a service, or if you are using a cloud that provides this kind of stuff as a service, the argument would be the time that it takes to spin up these things or get your container or your function or your whatever set up and running you shouldn't be charged for that. You should only charge for the time that your function executes. Yeah,
exactly. So again, depending on who your provider is, like they'll usually have like per second billing or per minute billing. Mm. And again, it's the utility, right? So the more you use, the more you pay. The less you use, the less you pay.
Right. Yeah. The idea that the outer loop of the setup and the getting the thing ready to go is free, and the inner loop would be what you pay for, would be pretty cool. So then it's like you start paying for CPU cycles.
Yeah, that's pretty much it. CPU cycles, memory, bandwidth. It's like if we use the example of S3 on Amazon, that's a pretty common service a lot of people use.
Mm-hmm.
I just want to say, okay, store these files for me, right? I'm going to create a bucket, right? Like a container for me to store this information in. And I'm going to just give you some stuff to store. Now, if I create this bucket and I don't put anything in there, then I'm not going to get charged for it, right? Because the bucket's there, but I'm not actually using it to do anything. When I start using it to do stuff, when I start taking up space or using bandwidth or anything of that sort, that's when the billing starts, right? So how much space am I taking up? How often am I accessing it? How often am I making requests here? Mm-hmm. And then you'll be billed accordingly for the usage, but not the provisioning of the resource.
Yeah. Well, and even better, if you could hide as much of the billing and as possible, like you're listing out the stuff that one could potentially bill. It'd be nice if you could remove as many of those things as possible. Like, I'm thinking of like, Azure Container Service, which, the management VMs, the cluster management, you don't pay for that, right? So you do pay for the VMs that your containers are running on. So that's on you, and you pay for those as virtual machines. But if you could hide the management, if you could hide as much of the bandwidth as possible, if you could hide as much of the storage as possible, that'd be cool.
Yeah, and they actually do a very similar thing with the Azure Container Service, the Azure Kubernetes Service. Like again, the management stuff you don't have to worry about. All I need to worry about is, hey, let me push this image, right? And then they'll worry about provisioning some of that stuff for you. So that works out really good.
Yeah. So do you think that a year from now, 2 years from now, there will be a generation of people who don't think about Kubernetes, they don't think about VMs, they just check a box or pull a slider bar and their code shows up somewhere? And then there's the DevOps people are the only ones that know or understand.
So I've definitely spoken to a few companies that they're like 100% serverless. For instance, I know that there are a few, what do you call them? Video hosting websites, mm-hmm. right? So they do like educational learning through, hosted video and things of that nature. And a lot of them are completely serverless now. So again, they have serverless storage, so to speak, right? Their applications are built on serverless APIs, and then their front ends are just, thick JavaScript clients that are calling these serverless APIs in the background. So again, no servers, no, machines to worry about, no VM updates. And that's essentially how they run. And it works great for them because now, like, they only pay for what they use, right? So, I don't have to be, okay, this is going to be a very heavy, sales season for me. I have to, expand, and buy additional servers. Like the platform just automatically scales up and scales down. And that works really well for them from a cost perspective.
And do you see this, taking over like all of computing? Because I feel like when I teach people software, and I assume you do the same, I either start at functions or I start at websites, and then I try to find a website that I can throw up as quickly as possible so that people feel, happy and comfortable, which is usually platform as a service. Do you think that will be hidden from, new learners entirely?
I don't think so. I think, kind of like computing in general, this is the kind of way that I look at it, is we all operate at a different level of abstraction, right? Okay. And as you're building out your solution, you have to find out the level of abstraction that makes sense for you. Just like we still have tons of people that are running virtual machines, right? And that makes sense for them, right? Because they need to have that level of control over their environment. Then you have, again, the platform as a service type offering where, well, I don't really worry about the VM in terms of managing it, but I do say, hey, I want it to be this big and this fast, right? Like I want this much RAM and I want this much CPU, and I want it to scale based on some predefined rules that you set up. But at the end of the day, like that level of abstraction works for them, right? So serverless now is like a higher level of abstraction. This is the level of abstraction where we just say, here's the code. Let me know how much money I have for you. Because I don't really care about worrying about some of these other things.
Is it their comfort level though? Or is it, are people picking VMs because they are comfortable with it? Or are you saying that they actually have a business reason to care about the VM?
And I think there's a little bit of both, right? So for some people, definitely do have a business reason for that, right? Because, again, depending on the type of industry you're in, you might have certain requirements, particularly when it comes to compliance and things of that nature, that, you need to have some level of like a deeper level of control. Again, when we talk about auditing and things of that nature, like you might need to do that. But also too, from a comfort level, when you think about onboarding new developers and getting people into the crowd really quickly, imagine you have a new developer that starts today and you say, hey, I will need you to go look at this API. It's serverless and it's running, it's running in the cloud. I need you to go update this code. Well, you know what they could do? They could check out the code, they could update it, and they could push it. And then, probably in a couple of seconds, they could actually see like the results of that change, like in a real environment.
Right, exactly.
Right. Versus being like, okay, I need to set up this virtual machine locally on my laptop. Mm-hmm. I'd have to get all the settings right, the configurations right. I got to get the right dependencies and DLLs installed and all this types of stuff. And then I still may not even get it right because I gotta, there's a lot of tweaking and changing that needs to happen. At least with serverless, you have a little bit more of a consistent environment, right? So when we talk about time to change, when we talk about an increase in level of productivity, that for you might be like an acceptable level of abstraction to be at for those particular gains.
Nice. So you, as I said before, are the host of Away from the Keyboard. It's a podcast. Is it a tech podcast or is it a people podcast?
It's a little bit of both, right? So at the show, what we do is we talk to mainly different folks in the technology industry, but we talk to them about not technology, right? So again, if you work on company XYZ and you're into this compiler and that programming language, that's great. Kudos to you. We don't really want to talk about that. What we do want to talk about is, what are you actually doing? Like what really motivates you? What really pushes you? Like what are the things that really get you going as an individual? Mm-hmm. And I think those are important stories to tell because now you can kind of get to see, what's the journey this person kind of took to be where they are today? Like what are some of the hurdles they had to cross? Or, what are some of the things that they do to kind of de-stress when they're not working? And now you get to see, let's say Scott, right? Like we get to see Scott as a person, right? We get to see Cecil as a person and not just, somebody on YouTube or a name in a book that you happen to pick up in the bookstore.
Mm-hmm. Very cool. Well, thank you for coming on my podcast and we'll be sure to check out yours.
Thank you so much, Scott. It's been a pleasure.
This has been another episode of Hansel Minutes and we'll see you again next week.